Everybody knows that Newton's second law of motion is the sum of the forces is equal to the mass of the object or objects multiplied by its acceleration, and that this is what governs how things move. That's what all our physics teachers taught us anyways. But is that really correct? Is it really right? No, it's wrong. Well, mostly. Newton actually defined force as the change in momentum over time. And he actually had to invent calculus to do that. Now, momentum is defined as the mass of the object multiplied by its velocity. Now, if you want to find the change in that momentum, you have to do a little calculus. And it comes out to this. Your change in momentum is equal to the opposite of the velocity times the change in mass plus the mass multiplied by the change in velocity. Now this is negative because the velocity of the change in mass is going in the opposite direction of the force. And you simplify that, do a little bit of algebra and substitution. You got the sum of the forces, because we defined that already as the change in momentum, plus that velocity times the change in mass is equal to the mass times the acceleration. Now you'll notice that that looks a lot like the equation in the first slide, that force equals mass times acceleration. We just added a new term. Now usually that change in mass is either negligible or absent. And you can just take it out of the equation usually. That's convenient because that change in mass can be pretty complicated. And so your textbook and your physics teachers will usually ignore it. But it sometimes is important, as is the case of rockets. Now somebody smart a long time ago figured out a simpler form of this equation for rockets. He said that the change in velocity of the rocket itself is equal to the velocity of the exhaust times the natural log of the initial mass of the rocket over the final mass of the rocket. See, all this stuff coming out of the rocket is that V is the velocity of the exhaust multiplied by the change in the mass of the rocket, because all that exhaust is coming out. So obviously that term is important. And as you can imagine, that change in mass changes over time because the fuel gets used up a little bit at a time, and it gets really complicated.
Oh, Lionel, glad you could make it. Can I get you a drink?
Yeah, something soft. I'm driving. Parking's an absolute nightmare around here, isn't it? Had to reverse into the tiniest of spaces. Still, I managed it. I mean, parking's not exactly brain surgery, is it? And I should know.
Why is that? Are you a doctor?
Careful. Not a doctor. I'm a brain surgeon. Big difference. Big difference. Yeah, I actually know a joke about this. What's the difference between a doctor and a brain surgeon? One's not exactly brain surgery. The other is brain surgery. So, what do you guys do?
I'm an accountant.
Oh, that's good. Yeah, I could do with an accountant. Filling in those tax forms can get really confusing, can't it? Still, it's not exactly brain surgery, is it? I mean, brain surgery, believe me, is very complex. Are you an accountant too?
No, I work for a charity.
Oh, that's a very selfless job, isn't it? I really admire you. I don't think I could ever do what you do. I say that because it's emotionally draining, not because it's hard. I mean, it's not exactly brain surgery, is it? Which, as a brain surgeon, is what I do.
Lionel, here's your drink. Lionel's a brain surgeon, you know.
Yeah, he mentioned it.
Oh, Jeff, they keep you late at the Space Centre.
As always.
And this food round. Have you met Lionel?
No, hello, Lionel.
So, Jeff, how do you earn a crust?
Well, I'm a scientist. I work mainly with rockets. It's pretty tough work. What do you do?
Why, I don't mean to boast, but I'm a brain surgeon.
Brain surgery. Not exactly rocket science, is it?